Hello everyone. Today I want to start explaining about using OpenGL and GLSL shaders for image processing that I feel that quite powerful tool and much easy to start than just maybe using some Python scripting or C++ or any other low-level coding like CUDA or OpenCL. I will explain why it's easy to start. In same moment, maybe you can feel that it too limited, but to be honest, for most of tasks we often can need in our photogrammetry processing, they can be done using OpenGL and GLSL. And even if at this moment some more modern languages or API like Vulkan, like more low-level Metal on Apple devices or CUDA on NVIDIA, it's still pretty robust and still can handle high resolution images. And the best thing that it's quite fast to iterate, and mainly because for OpenGL it's so easy to find some live debuggers, even web-based like Shudder or application for macOS. It's possible to find some live shader tools. For Windows it's a lot of different, some people using Unity or Godot. I think it's nice because you maybe can learn something more than just image processing. But I personally prefer to have dedicated tools, and for that, for our working tasks, I first made a RawGL command line batch processing tool that use OpenGL GLSL shaders to manipulate with images. And when I look into some editors like debuggers that can do this in the moment I coding, I found several tools. If you read my article about RawGL on my Patreon, I thought you maybe have seen Shudder open source debugger, but because the coder who did this tool abandoned this one, and after some research I found another one, GPUPad, that when I start to better understand OpenGL, how it's work under the hood, I found much more powerful and more flexible for what it's need to do. So for that, for that stream, let's first maybe quickly check what these tools are. Okay, so GPUPad. Let me. Yeah, so it's on GitHub. GPUPad. Link I will later add to the description. So main features. This tool is GPL 3.0 license. That's amazing. So we can use this everywhere on any devices, as much installation as we want. It's cross-platform. I think it's technically possible to compile it for macOS, but the main problem that macOS already removed support for OpenGL, for latest version of OpenGL. It can handle not only GLSL shaders, but HDRI shaders that more common for Windows platform, and for Unity it can handle JavaScript and Lua syntax. This one I think more to simulate some web-based WebGL shaders, and so it have pretty nice graphic user interface, and it's really powerful. So this is GPUPad when you start. So here you can later learn. The thing that to start in the help menu, open samples, we can open different examples of using. Let's check, for example, cube. So here, how to say, kind of OpenGL program. I will later explain some of these lines and what they mean, but just to start, so it automatically run, and we can zoom in, zoom out, or some other. So what we mostly will interesting in its inside the program is the shader. VS is a vertex shader, and FS is a fragment shader. So nothing may be interesting here. Okay, let's try to open shader type print. Oh, compute. Yeah, compute shader. This one I'm not sure I will cover in this stream. It's about computing shaders. I'm not pretty well understand computer shaders, and RawGL have some issues with computer shaders that I need to fix. But again, it's another kind of shaders. Computer shaders was introduced on OpenGL version number 4 and later. So here we have version 4.3. Okay, let's get GLF. Yeah, but sample math G. So it's possible to check different examples. Let me check sync this distillation video. Okay, let's see a video program. Robin. Samples. Oh, maybe it's corrupted. No. Okay, let's close. Yeah, this one. Yeah, so automatic. So this one run one frame at time and stop, and this one processing kind of in real time. Okay, let's close this one. So what's it actually doing? Yeah, I think it's texture UV. Yeah, so it's distorting UV coordinates and using time frame. So it's kind of create this sine wave animation. But yeah, so you should check how this work. Attributes vs texture. Yeah, so most interesting for us is to the start the quad shader from examples, and here we can see the basic structure of GPUPad project. Usually I prefer to put preview here and shaders open somewhere in the center. Okay, we don't need real-time updates. Your texture, your color. Okay, so roughly, I hope you kind of understand. So graphic interface, pretty common menus. All other we will watch later. And my RawGL GitHub. Yeah, and my RawGL command line image processing tool. Not so much user interface because it's command line, but the main thing here that it's a kind of very minimal OpenGL program that can load. Let's test examples. So command line tool that have different options, command line options that can load fragment and vertex shaders. The where we can also define some variables from command line, pass some images, and we can render frame buffer into the output image with some options that handled by OpenImageIO. So because this is a command line, I first need to create this shader, and as a graphic designer in the past and just visual person, I always prefer to do this with something that can quickly show me results, because I can do mistakes in code, and like not only errors in program, but like logical errors, and with live preview I can quickly see that something wrong. And why GPUPad is great for this, because I can create the shader files that can be directly used from created in GPUPad, can be directly used in RawGL, in case you don't use some debugging features of GPUPad. But I will show how this works. So just in that case, this shader will give you error in RawGL, and you just need to remember that you need to remove these lines of code. Okay, let's start from something simple. GPUPad. Okay, it's simple and quite hard in the same moment. So what we can do, or we can just open Quad, or we can create a new project from scratch. And here I will create new project from scratch. I hope I will not do some errors, but let's open another one and just let's stop. Yeah, if you can see if shader not running, program not running, it's bright. By the way, you can also change some color. Where's custom help? Preference. Edit. View. So you can change window theme, editor theme, but I prefer dark theme. Okay. So how OpenGL work? So to run OpenGL shader, it's mandatory to create some I will say some maybe stupid words. I think people, the coders who perfectly understand, will have a facepalm on what I will speak about right now, but at least maybe for you just to quickly understand. So we need a target. The target is target that we will render. Target have attachment, and attachment is a texture. Don't know why it's somewhere on top, I prefer to follow original GPUPad order. So the texture that we will render, actually we can rename render. So attachment, we choose the render. I think we can ignore it this moment, but there is some OpenGL settings for attachment itself. The render here, what kind of render it will be? I think let's choose 2D texture. At least RawGL can work with 2D texture at this moment. I planning to implement multi-sample, but just don't have the time to create a multi-sample, and in most cases I wasn't need any multi-sample renderers in RawGL for most of tasks for a couple of years when I using OpenGL. So let's set 2D format. It's better left here RGBA. It's better set to 16-bit, and let's say something slightly bigger, 2K for example. Oh. So attachment, what's next? We will, okay, let me think. Okay, let's in this example we have image that shader loading, but let's start without texture. So what's next? It's a binding. It's okay. So next one, we need a program. Add a program. It creates the one shader already, and for that I usually have quad vertex shader that identical to attributeless.vs shader code from GPUPad. Just one thing, that instead of using version 3.3 of OpenGL, that I think the latest one that's supported in macOS, I usually work on the latest OpenGL version, 4.6, because I only work in Windows. So only one thing that I changed version 4.6 core, and I just have a copy of this file and I can load. By the way, it's sample squad. Yes, yeah. GLSL quad vert. I prefer to use .vert and .frag because this format I start to use when Ivan made the earliest prototype of RawGL. So from that moment, when I still use .vert and .frag extension. Okay, so here, and I need, yeah, it's already set to vertex, language GLSL, and right click, I need to add the shader, and again I have an empty frag shader and that we can double click. Let's close this one, untitle it, and quad. So we have and fragment shader. I need to change to fragment shader. And let's maybe save. By the way, yeah, so it's better click somewhere. Okay, the save untitled session. GPUPad quite stable, but as soon as we working with such low level things and programming, it's always better to save your process sometime. Okay, let's name this start. That's the name, start. And let's see. Okay. Okay, save. Can I save reloads? Maybe because I don't change it. Okay. What's next? And so here we defined the shader program, and that's maybe what we need to call these shaders. So we need to do two OpenGL calls. For that we're adding other call, and first we need to clean the buffer. So for that, let's rename this call to the clean. Again, it's not a mandatory, but GPUPad use this, and it's just for yourself too easy to understand. Let's choose, so we need clear texture. Yeah, clear texture, every evaluation, and what the texture we need to clear, it's render texture. So every time this kind of program run, it will clean the render texture, and here we can define which color we will need to clean. And after that we need actual draw call. Let's again rename it to draw call. Here we need to choose what program it should run, the program, and target is a target, so this target, vertex stream, let me check. Yeah, vertex stream is not use it. Something more game devish like, or things that I don't really use, and because we'll work with we will use image that will fill whole buffer. So we need to draw a quad that will fill whole buffer. We define it, And for that we need to define what kind of how we'll draw this quad. And for that I think triangle strip, yeah, triangle strip will have 4 vertices. Yeah, one instance, first vertex is 0, and in other tools you usually can define these vertex coordinates, the quad coordinates inside the C++ code, but here GPUPad use this kind of thing, so it defines how much vertices the shader have, but actual coordinates are defined in vertex shader. I think it's too loud music. Okay, so and triangle strip, I will not explain how this works. For that I highly recommend you to check Chronos.org and OpenGL wiki about OpenGL shading language and OpenGL itself. It's actually another things like books of shaders, amazing learning about OpenGL and its shaders with a lot wrote by Patricio Gonzalez Vivo, amazing guy who doing GLSL viewer and doing a lot of interesting things with shaders. It have translation to different languages, so it's explain a lot of things. So for more deep understanding of OpenGL shaders, you can just look books of shaders. And actually, I think on Chronos.org it was OpenGL reference pages, resources. So it's a lot of links for some other interesting learning pages, articles about OpenGL and anything about this. So back to our program. So we set define the vertex coordinates. I think so. If our buffer looks like this, so again I always forgot GLSL 0 maybe here, 0 0 maybe here, and 1 plus 1 is here, but so just don't worry about this, just maybe copy this one. And so here we define for first, for second, third and fourth vertices. We define the output uniform. No, it's input. Oh, so again, please read about OpenGL, and without this information it still can work with RawGL. So I trying to skip all these technical details, and this is some mandatory things So here we need to generate, define how GPU should rasterize this quad and output UV coordinates. So again, here just a copy from GPUPad. UV, GL coordinates, GL positions. And for RawGL, actually, I don't use this vertex. By the way, let me check what I have in RawGL. In RawGL, I have empty vertex. Yeah, so it's much simple. It's only output GL position, and as I remember, so you can see that for most image processing scripts in RawGL, I just use this simple vertex shader that much more simple than the one that need GPUPad, and it makes me only one thing that slightly different from RawGL. Okay, so as soon as we added this one, we can close, and let's save empty frag. Okay, so to save the shader itself, shader code, to as a new file, you need to click into editor window and save as. Let's name it start. Empty frag. Start frag. Okay, let's change and do this same. Start frag. And quad vertex, because we don't need to change. Let's leave this as is. And let's draw the simple shader just to see that it's work. So here we have on input UV coordinates that define it from 0, 0 to 1, 1. And we need to let's use them as a color source. So out sample is equal. Yeah, we use vec3. So vec3 mean vec3. vec4. Sorry. Vec4 mean that this is RGB and A. So GLSL shaders use C style code. Vec4. Okay, let's just create the first. Let's define kind of grayscale 0.5 for RGB and 1.0 for alpha channel, and let's start to run. Okay, kind of looks like it's run, no errors here, and let's double click Okay, we have our basic first shader, and the best thing that is run, and what we can do, we can just quickly add our own new, just quickly define, okay, let's 0 like pink or something, so we can experiment with different colors. Okay, let's like red one. One thing that we should remember, that we work with, and shaders actually work with float representation of colors, and our monitors is limited with cannot display values higher than 1.0, and even if we use float allow us to use negative numbers from like -1 or like 1000, our monitor is still limited to the range 0 to 1 point, and here, so just think that 1 point is equal to 100%. So here we have 100% red. Now we have 100% red and 100% green. This gives us yellow. And if we set B to 100%, we will have white color. So pretty simple. Yeah, maybe some things like VEC4 looks scaring, but when you just remember this, you can quickly handle this in your head. Okay, let's do some color magic. So we know that UV coordinates is vector 2D vector. So this means that UV is actually is made from UV point X and UV point Y. So it's have two components, UVX and UVY, and let's pass UV.X, UV.Y, and let's set to 0. Voila. So we have made pretty basic gradient. Let's maybe set 0. So this one UVX coordinates encode the gradient in red channel. UV.Y in green channel. We can easily move this to maybe Z channel if we want. .Y, the blue. But again, so you can play with this. .X. Oh. .Y. And yeah, by the way, we can always see here some errors, like if we forgot something, it will give us error, too little data in type constructor, and it's actually no, yeah, it show the line with 0 start frag and line number 15. Here the code expecting vector for D vector, and here we creating 4D vector, but inside this we have only 3 components, and this give us error. So we need to add missed component, and now we don't have any error. How much time was need to compute this one? Okay, let's just save. Save, yeah. Oh, no, we just need to save. Save. Just save. What if we want to invert chord, so to draw? Okay, let's maybe, let me think. So usually as soon as we work with 4D vector, what we can do, sometimes if I understand that I don't really need the alpha channel, and I can define the output as a vector 3 and maybe change render to RGB. Let's check here now, calling program. Okay, so here we still have implicit cost, so here we need to change to vec 3, and now we can remove. And let's imagine if I need to work with grayscale. Actually, there is no grayscale in OpenGL. It's a single channel, and let's imagine we have single channels. To create a single channel output, we need to change vector 3 to float. Give us error. Let's float. No, just. And as you can see, float output usually grayscale output as a red channel. I think maybe, yeah. So oh, by the way, yeah, in GPUPad you can define that we use only single channel. That's nice, by the way. And okay, let's uv.x. So here we have linear gradient, or horizontal, or like vertical. So I guess here we have 0, here we have 1.0 value. What if we want to flip this? To flip this, we just need 1.0 minus uv.y. So again, this is pretty simple. Change to the gradient. Okay, what if we want made the gradient that have maximum value in the center of image and have 0 on the sides. What we can do, 0.5, no, plus, okay, let me think. So here we have 0, we have, okay, so here we have 0.5. So, okay, let's create temporary fluid color is equal uv.x color. Okay, it's work. Let's color. So let's to have 0. Okay, let me think how I can do. I can multiply color 2.0. So here we have 1.0 and here we have values higher than 1, so up to 200%. No, maybe it's not a good idea. Okay, now color 1.0 minus color. So here we have what I'm doing. Okay, let's color equal absolute values of color. Okay, something weird I made, but this works. So I multiplied by 2. Let's maybe color divided by 2.0. No, I don't need. Okay. And again, color is equal 2.0 minus color. Okay, just a weird math without actual thinking. Can I? What if I will write down? Yeah, I think it's possible to do much easier. But again, kind of live coding, and I have results. Okay. What's next? What if we want to have another gradient? By the way, how many people watching my craziness? Someone watching. How much time? It's already? Who knows? So, okay. Okay, let's go back to some color representation. And what's I promise it? Okay, let's. So You can experiment with this, maybe using books of shaders. I'd have some nice examples, but roughly you can maybe get, but we don't need here this line. But let's go back to the colors. Let's change this to Vec 3. Let's change render target to RGB. Define color Vec 3 UV. Another way how we can write the same code, we can we can write like this UV and last component. The good thing that GLSL program can automatically, I don't remember how it's named, so it can autocomplete vector comp using vector 2D vector and last component like this. Okay, let's save all. And now let's add our image to load to see how we can import image. For that we need, okay, let's stop. Let's see how this done. File, yeah, 2D image. Let's add texture. Let's put okay, texture. Let me copy something. Yes. Not research. 3D. That's no. No. Okay, let me find quickly. And context D oops. Oh my god. Okay, wait. Okay, sorry. I need to find. Okay, looks like I found. Okay. So PNG. Okay, just use this as example. No, maybe not this one. View by large icons. Let's load something simple. So yeah, we can see it's quite big. Let's recognize it as RGB. I think as RGB. The one thing that probably I should ask a developer to do, automatically recognize the width and height for imported images, because if we want to work with the same image size, we need to copy these sizes to our render texture. Okay, and 180. Okay, yeah, so we can close. So now we see that render buffer have the size of image, but we still need to bind this texture into the shader, and for that we need to add the binding, and we need to name it. Let's name it as the input image texture buffer. No, sampler. So it should be sampler, and we choose the texture, and let's set so it's magnifying filter. Let's set to linear sampling, and mini file filter. Let's set linear map linear. I think we don't really need this anisotropic filtering, and I usually prefer to set wrapping to club to the border. It's OpenGL options how it will treat the values of UV coordinates if we'll try to sample coordinates that bigger or smaller, bigger than 1.0 or smaller than 0.0. And here how it will recognize these coordinates. In case of clump to border, it will automatically clump the values to the border value. So if, for example, this one 0.0, if we'll try to sample 0.0 minus something, it will automatically clump to kind of the last pixels in this line here and there. I found this more usable for some convolution image processing, but we can clump to the edge. In that case, it will set to the border colors, and it can mirror repeat. In that case, it will kind of flip image to the side, and kind of will be sample pixels from here, or just repeat. It will automatically, so if otherwise coordinates go here, it will repeat from this side. In some cases this needed, but I usually by default you prefer to set to like this. And here what we need to change, input EMG. Okay. And now, okay, let's just automatically, so to load, actually it's not a load, but to visualize our image, we need write this kind of code. Texture. Okay, let's texture. Input image UV, and I think that's yeah. So it's correct, but texture function. But let's GLSL where's reference. GLSL texture function. Yeah, so OpenGL 4.5 reference pages, actually they are identical to 4.6. Here the list of all OpenGL functions, and right now I use the texture, so we can always see the documentation about this function. And here we see that this function always have vector 4 output. And what's this mean? So our outsample have vector 3D vector, but texture load RGBA. Even if we don't have alpha channel, it's still kind of creating. And to eliminate this error, we can use swizzling, so we can dot RGB. And here we have our output with no errors. But we see that image looks flipped, and when we do actual processing in RawGL, we can ignore, because we kind of load an output. But in OpenGL GLSL debuggers, we see how this actually working. And good thing that GPUPad have option to flip vertices, I think. So it's better to flip it here, but at the same time it can do flip on load. And that one I don't recommend to have, because in that case, if we will work with photometric stereo, this can give us that our code will not with RawGL, because in RawGL I do not flip image on loading, just to minimize any internal processing. So let's left flip vert here in image in 2D texture options, disable it, but enable flip vertical, flip by vertical. Yeah. Another good thing in GPUPad that you can zoom in, zoom out, and this live view. Use the size, I think. So this is a full resolution image, equal this one. Okay, let's save all. So here we loaded our image to this shader, and by the way, okay, let's maybe do next step one by one. Now let's do some color processing. Let me think a little bit. Let me open this image. PNG 17. Okay, let's open index and view. So I think this image file image console properties info, no, not this. Okay, let's open in Photoshop, because I want to see if it's this image in sRGB or not sRGB. So GPUPad itself is color space agnostic, so it don't know what color space we're working, and for some tasks it's better to remember what actually color space we work. I think RGB depth stencil. Actually, OpenGL have option to which color space, but I think yeah, in case of sRGB it was maybe sRGB here, and then shader will do automatically sRGB to linear conversion, but here it just load pixel values as they are. Okay, let me assign profile. Yeah, I think it's sRGB. Let me change color settings. Assign. Yeah, if it was not sRGB, then we had something like this. Okay, let me change back color settings. Custom. Okay. Let's do some color manipulation. So right now we understand that this is sRGB image, and we already kind of loaded this image to our GPU. And by the way, even if this image is 16-bit integer, we can check. So let's say we'll try to multiply many times, it will be clumped to 100% values. So even if we have integer image on input in the shader, it automatically convert to some sort of float representation, and inside our main code we work with the float values. So all these images converted from maybe like 0%, 0.0 float to this white maybe 100 or 1.1%. And here we have vector 3D vector with 3 float components. And just to quickly do some float math. So what we can do, we can just, let's say we want make it 50% darker, and for that we can just or divide by 2.0, so this is 50% darker, or we can multiply by 0.5 or like 25. And again, by the way, we can, because we use C code here, we can do like this. So this means that multiply our values inside, what's name? I think it should be some name for this kind of operation when you in place do multiplication. Or let's think we want do a grayscale. For that we can do a construct vec3 and no, we need, let me think how we can do this. So we need to sum all outsample channels. By the way, we can work with single channels, single components using this notation, .r plus .g plus .b. In the same moment we can use XYZ. It's absolutely identical to this, and RGBA will equal XYZW, and probably one more, but usually RGBA and XYZW. And it's common practice name RGB and A when you work in standard range from 0 to 1. So here, as soon as we work with 0 to 1, let's use RGB. If we'll use with negative values or high dynamic range, in that moment we will switch to use XYZ. Even if they will mean the same, it will easy for us to understand that here we're working with values that or have negative values. So non-normalized range. This one RGB is normalized range. Okay, let's sum up all values and divide by 3.0. And here we have arrow that implicit cast from floor to vec3. The shaders cannot do like this automatically, and what we can do to fix this arrow, we can do so we can do float. Sorry, so error, because our sample should be a 3D vector. Let's do like this, float gray. Error was gone, but we don't have grayscale here because it output this value. And let's out sample. Out sample is equal gray, and do is use a swizzle xxx. Voila, we have our grayscale. How also so this one is a simple 33.33 in period percent of every channel. We did the grayscale. Let's imagine that we want to do some. Okay, let's think RGB to grayscale formula. So RGB converted to grayscale using NTSC formula. For example, two slashes is a command line. Let's imagine that we want to use NTSC formula to grayscale. We can do this by actual math. In that case, by the way, we can see, so I remove it, division, and here we have values that are bigger than 100%. Okay, so we can just add a multiplication. Yeah, by the way, GLSL shader to define float values don't need F letter. In some cases, if you use GLSL for embedded systems, GLSL ES, it can give error. I think RawGL and GPUPad don't give any errors. Shader Toy will give an error in that case if you write, so just better to not write F. Okay, 0.7 multiply and 0.1 multiply. So here we kind of hard-coded NTSC grayscale formula, or we can use I love to use dot product for grayscaling, and let's create vec3. Its name is gr vec3 99 7 1 1 4, and let's use dot product. Oh, don't remember which one should be first. Let's check how to complete sample gr. Yeah, I think maybe it's not any difference to use the order. So, and now I can easily change how many percent. So if I want to use less, like 10%, let me think. Actually, we can even do, okay, let's, so yeah, so kind of I can quickly change how many percent I want to give for specific component here. But one thing that we should remember, in that case, if we we need to normalize this vector to have grayscale result. Also normalize it in 0 to 100% range. And what we can actually do here, we can use normalize function of OpenGL gr. So it automatically normalize the values. So create the okay, let me think. Maybe it's not. Let me check. Normalize. No, I think, and we need to do square root. Wait, let me think a little bit. If we normalize the vector, then the length of this vector is equal 1.0. But this not mean that the sum of its component is 1.0. To normalize this, no, I think we should not use normalize. Plot and gr x quick jar.z. This is the sum, and we need to divide our by n. Yeah, I think this one is correct. Let's try. Yeah, so even if we set to extremely high, we'll have in that case we'll have normalize it. And how we can maybe they can do something like this, and in that case we can like set 30%. Actually, we even can use not float. Okay, let's say 30, 40%, and again 30%, or like 10%, 50%, 40%. In case we'll do this 400%, then actually these values will be automatically reduced. So the total after this line, total sum of all components will be 100%, and here we'll have 100% color values. But again, it's some math that you can, it maybe looks scaring on some moment, but actually pretty simple. And when you will start to understand how these values actually work, it will become more common for you. So we actually can do these kind of things. So we can OpenGL and GLSL can automatically recognize this code, and it will be expanded to vector 3 like this. So if in case we want the same size, same value for all components, we just can write the one. Yeah, actually, because we have this line of code that normalize our value, we can write. So all channels are equal. Okay, let's do other thing with this before we'll do some actual magic. What we can do, the thing that I really like in GLSL, that in case I need to work with channels, I can do this kind of for free. So let's think if I need to swap R and G channel, and to do that I can just write like this, R, B, G. Okay, we swap it B and G channel, or we can change like this, or RG, or actually we can do like this. So yeah, if I need only red channel, I can write like this, only green channel. only blue channel. So it's easy how quickly I can check what's happened inside channel, change their order, and it's immediately happen. Okay, let's think. Let's compile the normals for this photometric stereo input. So we need to load how much? Okay, let's maybe start. Okay. Actually, OpenGL have some dedicated thing for this. How it's named? It's texture 3D, I think. Texture 3D, but RawGL don't have implementation for that. So we need to load one image by one. But again, let's try to do this. I think it should support drag and drop. Yes, so it supports drag and drop. Only thing, I see, so it not, by drag and drop it not recognize it. Okay, let's 2, 3. I hope I will not hit the limitation of OpenGL, but I think it should support 17 images. Number 4, 5, 6. Oof. Okay, let's try. Let's pause. Let's rename new folder with no, let's do something. Let me think. Okay, let's delete everything. Image. Let me find another example. Let me think. Hmm. Okay. Name. I thought I have prepared files, but okay. Yeah, let's maybe look. Save images. Name. What we should use. Okay, let's use JPEG maximum quality. Default size. Let's percentage 50%. Maximum. Okay. Done. Okay. Name it left. Right. Back. Okay, it's bottom. Name. In that case, no. Okay, sorry. Let's delete everything and boom. Okay, let's do the same. The crop. Look at. Oh. Synchronize. Sync settings. Okay, crop. Geometry. Okay, save images. Well, it's actually should be a RGB, or at least like for photo something. 50%. Okay. Yeah, I think it's better. Done. Bum 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 bum. So. A texture. Front. Texture front. Let's rename font. How much? Oh, it's not so bad. Actually, we don't need RGB. Ah, that's left. Блин. What? Yeah, I think I did it correctly. Texture, add texture. Front, back. Back. Wait, what? Okay. It was left. Okay. Right. Left, right. Top and bottom. Top and bottom. So we added textures. Now we need to create the bindings. Copy, maybe paste. We need 6 of them. Front, back, left. Rename. Left. Right. Left, right. Right, left, right. Top. Bottom. front, back, left, right, top, and bottom. So here we create the bindings, and now we need to add the actual code here. So we don't have input image anymore. We have front. In my introduction to RawGL, I mentioned that it's possible to not use layout keyword and just like write like this directly. Let's do this. It's a good practice in case we would want to use Spear V binary shaders later. And here I define which binding slots will be used for our textures. Front, back, left, well, right, top, bottom. Let's name out normals. Yeah, let's left this as vector 3, and it's interesting. So let's run. Okay, undefined variable, undefined. Image set not set, so it gives us a lot of errors, but still kind of running, and we can see this kind of white if you're using other theme. It will other colors, but this means this inputs are inactive. But let's save start frag. It's actually nice, but let's rename it to rename PS frag. Let's replace start PS frag. Okay, save all. And what's we now need to do? By the way, linear. We actually need to, but because we copied, we have everything set, so it's nice. Clumped border. Yeah, perfect. Let's first try to load, and let's first we have out normals, and we don't need this one, for example. Instead of using just a texture, let's use texture load. I think, yeah, this one. Again, I usually prefer to have this one because in that case I can explicitly set that I want to use load number 0, so no interpolation will happen in case of fetching pixel values from sampler, from textures. And let's load the front. Okay, yeah, and we need to change frame buffer to this. And and by the way, as soon as we have actual code working, these inputs become active. So here we have front, we can change to the back, we change to the left, etc. How we can do? Now let's integrate our photometric stereo inputs into normals. For that we use pretty standard thing. Let's ignore this fact that this is sRGB, but we need to work in linear space. But what we really need, so we have front, back, left, right, top and bottom. If front and back is a Z component, so Z component is equal front minus back. Y component is equal it's top minus bottom component, and Z component is equal not Z, X component is let's say right minus left. But we have here, we have RGB that we need to convert to grayscale. And let's do maybe this kind of most naive way. Let's create, let me think. Okay, let's create vec3 x comp, and for that okay, let's do some output to preview. Out normals is equal x comp, for example. So here we have left, but we should have right. And let's just write here the same. By the way, minus the same we have black, and just rename left. Let's don't worry. Okay, so we minus right from minus left, and but doing this per channel to see what actually happened here. So here we have positive values and negative values. Let's add debugging information, and for that computer printf. Then nice thing in GPUPad that you can do some kind of debugging. You can see you have hello world output. It shows us these lines where our mouse actually moving, and it shows us the color values here and also show the coordinates. Let's see how this actually doing. So it have this print enabled definition. It have print hello world, print like this, print like this. The things this actually have here. So this work in GPUPad only because it's not a part of GLSL language, and I think I don't read the code of GPUPad, but I think it kind of filter out the shader code before passing this to OpenGL and interpret these lines as direction for GPUPad itself. But what we need to add this thing. So we need to add the binding uniform and with value mouse frag chords. The binding uniform expression. Yeah, expression mouse frag chord, and that we need to rename this mouse frag chord, because that we will use, and let's put it somewhere to our fragment coordinates. We need to have this line here, and we need to have them here. It's maybe good practice, and let's put it somewhere here and add the command for us: debug code, debug and code. So we need to later, if we will want to use this code in RawGL, we need to remove this text, or RawGL will give us errors. Okay, so we have here, we need to print enabled. Actually, I don't know, should we? Yeah, I think it's mandatory. Again, debug code, debug and code enabled, and coordinates. Maybe it's mandatory for this one. Okay, let's copy this code here. Color, and let's move to the end. It gives us no variables or color. In this shader example, it's O color is output. So instead of using O color, we need to use out normals. And here we can see that we have coordinates and we have some values. But because it use IVEC, it's mean integer 2D vector but we use floats, so we need to change to vec2 and change f. Coordinates here in pixels. No, sorry. This one, coordinates in IVEC. By the way, coordinates uniform vector, yeah. But here we unsigned integer. We should change to this one. Yeah, and it now. Why so big? Mouse coordinates vec3. Because yeah, floats and here integer. Yeah. So here we can see now color coordinates here and values. That's quite useful. So we can zoom. It can sample in these coordinates. But I usually prefer to see. And for that, I can quickly normalize the coordinates. So here we have from -1 to +1. We need to normalize to 0, 0 to 1. For that we need to divide by 2, 5, and add 0.5. And here we can see something in range from 0 to 1. Okay, let's add another component, x, y component, top minus bottom, and let's change to y component. Yeah, now we have this one, and let's add a z component. Front, back, and let's rename it to z component. So here we have these components. Now we need to grayscale them, and let's do again nav float x equal x comp x plus y plus z. As soon as here we have range that don't fit into 0.1 but -1 to +1, I changing to using XYZ. Okay, and again, and divide by 3.0. And let's see if we'll change X, give us error. Let's quickly XXX. So here we have our X component. Let's do the same X, Y component. And let's do the same for Z component. Let's check Z, Y x. Again, everything here can be right in more optimal way. I can maybe use a dot product. I can create another function that will call this, and by the way, I will do that. But when I prototyping some ideas, I quite often write like this, because yeah, it's easy for me to remember that like grayscale is sum of all channels and divided by 3. Then later I need to do something with this, like minus here. So just I usually prefer to see results and see if my idea can work or not. After that I start to do some optimization. Okay, so now we have XYZ component, and again now we need to create vector 3D vector x y z, and here we have but again we have from minus to plus, and again let's normalize this. By the way, I think it's possible to do not write first 0, but I usually prefer. And here we have raw photometric stereo normals. But if you remember my article, that we need to normalize. And again, let's name this vec3 form is equal normals equal norm. Now we need to normalize, and in OpenGL it's a single line. Norm is equal normalize norm. Did I make some mistake? Or maybe not. Yeah, I think so. Why it's normalize? Is okay. Yeah, mistake, because I made this in when I should do this here. No, norm. Yeah. Well, sometimes this happens. Yeah. So no, so we create the component and we normalize it, and now we need to use for voila. So this is the photometric stereo normals for light stage type of systems with light dome, because it's much easier to show how this works. What's here we should do? At first I see a lot of kind of noise here, and actually that can happen because it can be 0 size vectors in this step. Normalize function is pretty dumb function, and it's not check if the vector is not 0. How normalization actually is working? Normalization is normalize. It create a magnitude of calculate magnitude of the vector, and for that it use to compute the magnitude, it use sum of oh, its name, the power of 2 of every component, is that after that it compute the length of this vector. For that it's take a square root of let's name this m. Yeah, let's name it m2. So m2, and after that it divide every component to this m. And because we're working with photometric stereo normals inputs, we can have the m is equal 0, and in that case divide by 0 will probably create some nonce. Oh, I don't remember how it's correctly named. So the values that should be not there, so incorrect numbers, and that actually can give us some errors. Or also this can be values too small, and for that I personally prefer to create my own wrapper for normalize function. I usually name this let's name vec3 norm and norm 3D. On input I use vec3 norm. Here and here I do some check if length of norm, if the length of the norm input vector is smaller than some, let's name it float, let's name it sigma, sigma is equal 0. Let's choose some small value. I don't think it's worth to set it too small or too big. So like this, it's already 1%. It's 0.1%. So I usually set like 1 per milli. So if vector length smaller than this sigma, then right, oh, I usually do this. Let me check. Okay, let's do this. I think it's okay. Yeah, return. In that case, I will return 0 size vector. And if the input vector is bigger than sigma, I will do return normalize norm. And instead of using normalize, let's use our new function. And you can see here, when I replace, it's kind of changes something. So here we removing some extreme values, or even this nonce. Okay, so here what we fixed. Now we need so actually here we're working with sRGB images, but we should use linear. And for that, we actually need to create another function. Vec3 sRGB to linear. And let's use the sampler 2D texture, no, let's text. And let me find, I remember I did some examples. Yes. Let's just copy to linear. Yeah. Just copy. Comment the colors to linear light, linear gamma from sRGB gamma. Here a little bit more cryptical code because it optimizes it as much as possible for OpenGL and GLSL. Try to avoid some branching like if-else statement, but again you can find this code in my RawGL article. And here I just will use so here I use sRGB. Well, okay, never mind. sRGB, but to linear, okay. Then let's split this. X plus vec3 x minus xmn left right sRGB y plus mn. And now let's just expel is equal to linear expel. Let's just, well, let's do one by one, because let's see the difference. mn z y. Okay, let's see. Expel. Okay, let's hide. In this one, and define it. Okay. Okay. So, for example, this one is a RGB image, and here how this image looks in linear space. So looks like this work. Now let's do X component to grayscale. Okay, let's next do a grayscale function vec3 to gray, vec3 RGB. Yeah, let's do this simple return RGB R blue plus RGB B plus RGB G. And let's slightly optimize. Instead of division, let's use multiplication, and let's do like this. Maybe this not needed in modern OpenGL, and maybe GPU do this kind of optimization itself, but like many years ago it was common instead of using division, but you actually use division. Okay, let's left. Let's divide by 3.0. Interesting. It looks like here no way to no, maybe it's not already not important. Okay, let's ignore my first thing. So this one function will return us grayscale, and let's do wait, it should return on float. Yes, now no errors. And let's to gray. To gray. Yeah, it's correct. Let's check. Yeah. Yeah, it looks like working. Okay. And let's do minus to gray minus. Yes, here we have our X component. As you can see, I slowly do more steps in the same line, because yeah, actually I don't really use when this kind of code where I do every line of code on for every step. Sometimes I can merge them if it's like too common for me. And yeah, just to optimize, and it's okay. Norm. What I did wrong. Normalize to gray. XYZ. Z minus. Okay, let's debug where I made mistake. Expel MN Z Y. Yeah, looks like it is correct. Maybe I made some mistake in X. Yes. What's wrong? Ah, yeah. Z. Ooh. Then ML. MN. Yes. Finally. Again, let's normalize 0.5. It's 0.5. Kind of we did this, by the way. We can play a little bit. Yeah, so it's actually this sigma in normalization can be used to filter out some vectors from background, but it's actually not so critical. Let me think how we can quickly check the difference between what we did with linearization and without linearization. Let's add one funny trick. We can use the mouse coordinates to split the window to before and after. And let's do this. If let me check. Yeah, I think this one. But instead of this, we will use this bigger uv.x and make 3, 5. X. No. Oh, I did this. Mouse coordinates in. Okay, we need how much size? Debug code. Let's move. This texture size. For texture size, let's use any of these images. Right. And it's required 0 load. Countable type vec2. And let's name vec2 is nice. How I doing this? Okay, let's maybe ux coordinates bigger than 0. Smaller. I forgot what. Okay, yeah. UV UVX. Okay, so looks like it was not needed. IVEC. UV. Size. Maybe and yeah. 1000, so size yes, so it should be divided by size. Back to your size coordinates. Maybe no. Two. Let me change to like this. Yeah. UVX. No. Yeah. Actually, UVX, its coordinate and okay, yeah. But let's change. So if mouse coordinate, let's name it mouse. So if mouse coordinate is bigger than UV coordinate, then made the paint with grayscale. But wait, why? Here we have 0. Don't need this line. UV coordinates is bigger. Okay, so yeah, it's kind of correct, but required a little bit brain thinking. And let's quickly, instead of this one, let's do just to gray. Without linear. Example to linear. One. Okay. XX equal gray x well minus n to gray. We still need, okay, back 3 and then back 3. X6 Y. That. So, okay, no euros. Euros and no. And 0.5. And actually, it's really hard to see the difference between linearized and non-linearized results. So I don't think on YouTube you will see this, but let me maybe how we can, let's maybe just you to see that it's actually work. I forgot. Okay. So yeah, here it's moving actually, and maybe only like here you can see a little small difference between results. But anyway, if we really want to be more precise and kind of avoid discussion about using CAS-RGB or not using CAS-RGB, we can see that technically using linear, non-linear don't give us too much precision, don't add too much precision, because it's a lot of more other errors and approximation in photometric stereo inputs. But yeah, so here what we have. And let's save all. Yeah, by the way, it's possible to export the render from this, but let's maybe first disable this if function, if part of code. For that we can actually use this way to define comment, to comment the code using slash asterisk slash. That will treat as a comment everything inside them. We can ignore this because this not used anymore, and actually big chance that even RawGL will just silently ignore this. But again, and let's first maybe save everything, and we can try to export. But let's see, at this moment it was some bug on export, and let me check test diff. Check the file name. Wait. Save as render PNG. So actually rendering to PNG is okay, but the best rate of this file support texture format. Yeah, I think this is a bug. So it only can write RGBA, but in that case we need change our code to vec4, and here we have out normals XYZ, out normals dot A. Yeah, so we should explicitly define that we have alpha channel equals 1.0, and then in that case it will save our file. So we have full size render output from GPUPad. What I don't really like here, that in that case you need to remember to not save this session, or it will, every time I will press save all, it will try to save the render, because it's only use PNG. In that case it will too slow every time. But let me press don't save, flip vertical. Okay, and now let's see how we can use this in RawGL quickly. For that, RawGL examples. Okay, let's copy example here. So here we need empty frag. Let's change to something more verbose. RawGL, where's the RawGL bin? RawGL. Maybe. Actually, maybe it should be there. Yeah, I think. So I need to define the path to the path size. Okay, in. We don't need this input variables. In test examples, now it's tests, frag pass, in sample. Let's copy this. Let's name front. 3, 4, 5, 6, 7. No. Front. Back. Left. Right. Top. Bottom. Inputs. Oops. Oh, it's okay. You need actually, yeah, we don't need. Well, anyway, I need GBeam. Back, front, top, front. Front. Let's just copy everything. And again, how to set up batch process scripts for RawGL you can find on my Patreon article. But here I just want to check, right, that our shader work directly. Back and output, let's name normal, and let's use TIFF RGB 16 3 channel top okay, and front. I think maybe like this. Announce shader file extension frag. Yeah, I forgot to rename base frag. PS frag. Frag. It's empty vert. Yeah, like this. GLSL empty vert quad, I think should be. Yeah, quad vert. Quad vert PS frag. Okay, PS. Okay, what print enable? Yeah, that as I told you. Yeah, so we need to comment everything up to this. Okay. Empty loop program output. Yeah. We have out normals, but here we name it. Okay. Now like this. Yes, perfect. So it's loaded. Uniform location, channel. How much time? So something about 1 second. I think because yes, I made mistake and I use it coadverts from GPUPad, but we don't really need in that case. Let's empty vert. Let's use empty vert. Empty vert. Where's frag? Ugly byte book. Okay, here we have working RawGL for single pass, single set of inputs. How to do this for batch processing, please read my pattern article, please. But anyway, we kind of create simple photometric stereo shader. For yeah, it's not so much time. I thought we will have time to do something like with this, but in that case we need to do the similar, load all these images to the shader, and let me think how we can, at least to show some idea. Let's save a copy, save as yes, full. Okay, let's stop. And look. Okay, let's trying to do this for maybe only this first. No, it's actually only for this one first. Oh. Okay. 17, 16, 15, 14, 13, 12. Whoa. 12, 11, 10, and 9. Binding front copy 17. Variables should not start with numbers. Let's S17. 16, 15, 14, 13, 12, 11, 10, and 9. 16, GPUPad is a open source tool, and it's one person doing this tool, so it's possible to expect that user experience is not the best possible, because good user experience required a lot of time. 17, 16, 15, 14. And but you could think that it's not required too often. At least 10.09. Okay, let's save all. And let's save as. Oh, by the way, let's rename it to the full. Yeah, nice, nice. Okay. Let's S17. Six, 7, 8, 8. Yeah, I hope I don't made any mistakes. Let's enable debugging. Let's just vec 3, but actually we don't. Let's texture load. Texture load. S17 UV 0. Back not set. Yeah. Let's delete everything. Where's the back? Left not set. No. Draw. Target. Program. Sampler. It's interesting. I think it's somewhere. Remember, save all. Okay, let's try to reload. Peaceful. What? Mouse. Yes. and draw. Save all. Okay, let's this all. GLSL feels full. Oh no, frag. Yeah. Okay, never mind. It's full. I wrote. Okay, and let's see. Where's full GPS state? And I think now is frag GPS state. I hope it uniform not set. Pass frag. Ah, yes, because I need this one. Pass full frag. Defined. Save all. Let's close all. Don't save. Okay. Undefined render. Right. Perfect. S17. S17. Yeah. Much better now. But we need to fix the size to yes. Okay, great. We have now let's quickly let's create float S17 is equal to linear to gray texture load S17 UV and 0. And yes, we need XYZ. So okay, now here we have float and kind of let's outnoise to show is 17 incompatible with 3 render RGB. Okay, where's this one? Almost, yeah, RGB. Yeah, kind of. So we have linear, and let's quickly do How much? 9. $16, $15, 14, 15, 12, 11, 10, 9. And do the same here. Oop. 16, 15, 14, 13, 12, 11, 10, 09. No euros. Perfect. If you remember my article, now we need multiply this black orb with normal color, and for that let me find where's actually this one, because I already did this once, and I will just copy and paste these values. Photometric steel, not this. Now. That's a problem. Okay, let's just normalize page. No, where's my samples? Yes, normalize it. Okay, let's maybe take this one and the probe. Yeah, maybe. Oh my god. Yeah, I need maybe another black pro blend. Okay, let's do this. So for how much? 17. We need how we can mount 32 don't. If I remember which colors I used. Okay, Let's switch to 32 bits. Don't rasterize. So what we need is create leg 3 and F17. Let's name leg 3. And okay, let's do okay, let's see, 17, 16, 16, 16. I got Vec 3 F16 Vec 3. We can close this one. By the way, no, it's too complicated, so I don't have time for this. Let's do brute force Vec 3 F15 is equal Vec 3. So here I define, I measure the colors using this stupid simple trick with multiplication of color. To be honest, I do often doing something like this because not every time I really want to write actual and perfect code before I will not really sure that idea I try to test is really working. And just to imagine a situation when I write some perfect clean code and at the end I found that this idea just not work. Okay. 3 F15. I thought we'll have time to try to do this in shaders, but I don't think so. Every time I doing it's too slow. Vec 3 F, and to be honest, it's possible to create the shader that will find this maximum value and give us these coordinates. But this kind of things is not best thing that you should do in the shaders, because it's too much overhead, and these kind of things usually kind of faster to do in much in code like OpenCV. Or just using Python something. But just as a practice to writing shaders and do kind of workarounds. Maybe first idea was to use compute shaders that I don't think we'll have any time to learn today, and again because I slightly abandoned RawGL for a long period of time and still not finished some critical things for compute shaders, the atomic counters. So I know how to do them, but because I tried to do them more unified to allow all possible user inputs, the task become much more complicated than I expected, and it's kind of in my to-do list. It should be in some moment of time, just not in this month, I think. So yeah, it's technically possible to use compute shader and sample like it's more like generic C kind of code, or it's even possible to use fragment shader with some tricks, kind of define the buffer, small buffer, define multiply by sample normal this probe, and pass results as a small texture to the final shader. And again, mainly because RawGL wasn't designed on start to serve these kind of things, the final code will work, but it will be differently suboptimal. It will be more like a crazy GLSL code. Okay, so we defined all found vectors, and now we need to multiply this grayscale by this vector, and we need to change the range and normalize. Let me maybe add one function, load minus range vic3 I don't like let's name vic v. result v. We need from 0, so we need multiply by 2 and minus 1, 2. M range. Let's reuse this. F17 is equal S17 multiplied by F17, and everything. No, we don't need. In that case, we actually don't need. Actually, let's do and just add multiplication S17, S16, S15. Oh. S14. Ow. S13. 12. 11. 10. S09. So yeah, I just measure this together. Range. Let's also add the range. Range. For actual shader code, I probably do some for loop, maybe use some arrays of values instead of doing this one by one, but just maybe to show how this works. So after this we have, so we multiply this vector and change the range of the vector from original 0, 1 range to -1 to +1 to normalize it range. And now we need just sum all of these vectors. F17 plus F16 plus F15 plus F14 plus F13 plus F12 plus F11 plus F10 plus F09 normals. Some root function type result. Yes, because it should be vec3. V. Undefined result. Return, because return. Okay, return. So here we have something, or at least it looks. how much we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now we need to divide the values by 9. And now we need to normalize out. Normals is equal norm 3D did I? Okay, let's disable. Yeah, minus. Okay. Okay, so looks like I made mistake. Okay, let's see if F17 is correct. 0.5. The white. Maybe Vec 3. I think it should be like this. So I need normalize the vector first, and only after that to multiply by a grayscale representation. Yeah, in that case the gray one, so the black is dark. Okay. Normals. Normalize. Um, 0.5. Yes, but looks like I did somewhere another mistake. At least it's already looks more like an actual code. If I will, so it's a blue one. Actually, this one is not needed because we're doing normalization and all vectors that bigger. Okay, let's add Vec3 and 0, 1. Okay, let's debug. Looks like I was wrong with No, it's actually it's work, but why not as I expecting? Yes, 09. If we don't use too linear, yeah, so this one more or less is okay. If I remove range from here, technically it's work maybe it's where I can make mistake. So this vector is this. Okay, 16, 15. No, I set them. Let me check. No, so this is not a gamma. If we remove oh no, I don't remember how I processed this. This one. Something that I'm missing. 17. That one is. Yeah, technically it's kind of creating for us normals. The out normals. Let's check per channel. External is yeah, from left to right, from top to bottom. Z channel too big. It's because I don't multiply it here. Plus 0.5. Yeah, maybe it's because here we have too strong Z component that we probably need to maybe let's make 3. Again, just some ugly hawks, similar to what I did in my article, just to show what 25. Wait, I removed the range. Too much blue. Yeah, maybe because it's a surging beam. These normal maps can be or cannot. No, this one, the result normal we have in object or world or camera space. So to work with these normal maps in the tangent space, we need to have mesh and make these normal maps to tangent space normal maps. But let me... Wow, I'm curious what I forgot. Maybe add instead? No. Let me think a little bit. So here I correctly normal. No, it's already should be normalized. This range is 12. Too linear, too gray. Technically, so idea is correct, just maybe some implementation wise. So again, I don't give you ready results. by engaging you to think how this can be done. So you always should use this only as a reference how to use this kind of tools instead of use this directly in your production. No, sorry, I give you some tools like RawGL or Unrubber or some other tools that I probably will release in some near future. But scanning photogrammetry, it's up for you. I just show how simple this can be if you know some coding, and you don't need to wait when someone will release graphic user interface tool. You always can do it yourself. Maybe if I will don't touch that channel, that's maybe, yeah, I think I got idea. Instead of let's divide X3 1.0 1.0, so we'll not divide our X and Y channel, but okay, no. That's funny. Let's first multiply. I still 25 dark. Okay, let's see one by one. F17. F17 almost no. Let's maybe remove this. F17. Yeah, it will be single color because we have only one channel and only one colors oriented to two colors. So already should give us some variation. But what if we just remove? Oops. Maybe someone see what's error I have. It's kind of drive me crazy. Blue channel is almost and normalize, normalize. Black. Now range back 370. Oh, it's so stupid. S16. 15. F15. 17. 16. 15. There's something wrong with colors. 10. Almost everything. Multiply. I made the error. Yes, then okay, if I F10, 17, I think. Oops. Let's F17 plus plus 9. Okay, outnormals. Outnormals. Did I? It's actually not so far. Range out normals range no something. Okay, kind of It's interesting. So at this moment, normals should look more like this. I think a RGB too linear. No. No. But yeah, kind of. So this is our X channel, Y channel, and the Z channel. Oh, yeah, it actually looks totally wrong. And curious what? Maybe a wrench? No? M wrench. Back 3. Again. In that case, no, no. 25? No. Let's maybe multiply by... Yeah, something with that component here, and I think... something stupid simple. I probably understand where I made a mistake, but XYZ. Maybe I'm missing some. Oh my god. Range. Minus. Wait, the range, I need multiply by 2 and minus 1. No, it's my... I still want to understand what here. It's almost front. It's a side. We have too much blue here. I definitely need to reduce some that component. That component. Reduce. Am I missing something? What if... Is that why? No. Any ideas? Sum of all vectors. And kind of average of them. In same moment, the channel have too much maybe I just put the colors incorrectly. $99. Okay. Okay, let's see F16. F16. Violet. Wait, maybe I should multiply by 2. This one? No. I feel so stupid. So black should be black. But the vector itself. Yeah, I think error here. Maybe the way how I sample these colors, and they actually can be I can be sure that these colors in monitor RGB. Yeah, something wrong here. How can I and yeah, something incorrectly with the channel. Yeah, it's bigger than should be. Okay, yeah, so looks like the way I sampling this values was kind of one-off mistake, as you can see. If I try to normalize this to valid normal vector range, it create me 1.5 value here when it should be 1.0. Yeah, I guess this one also not. What? So idea is correct, just a lot of errors in these steps, and that give us these incorrect results. So let's not waste the time anymore on this. Let's save all. Let's find something we can do with HDRI before. Yeah. So as I mentioned, no, it's kind of yeah. That channel in this example, especially because I don't use it these light vectors kind of to speed up, they already have some degradation on that channel, and the way how I just use it in Photoshop, because yeah, again, I made mistake, I don't use it linear sRGB mode to open images, so it kind of multiplied all these issues. It give me the final error. But again, how you can experiment with this if you just want to understand how shaders can help you, so you can bind all your images. You can define the vectors based on light probe, and convert to grayscale and linear, multiply these results by the vector, summarize all these vectors. This one is not needed, and do a normalize. After that, if all this measurement was correct, you will have more or less good camera space, or I don't know, maybe light space, something normals that can be used. If you want to do this more precise, then you need to more precise measure these light vectors, more to be aware about linearization of your light and the camera. So yeah, it's again still some sort of approximation, but again, just to show you how you can do this kind of things on another level. Okay, let's try to quickly maybe to do some HDRI. Hope I will not made a error. Let me think how I can find some example. Okay. HDRI. Just because last week we discussed it about HDRI on our Discord, 3D scanning Discord, and it can be a good example on how to use these kind of things. Browse with Excel view. Okay, how much? That's not so big. Which one we can use as a HDRI PS? Okay, let's open this full, maybe. Yes, full. Okay. Save yes, PS HDRI. And again, we don't need this. Let's stop. Let's again, doing this without any preparation, so it can be errors in what I'm doing. 0093 0093. Okay, it's loaded, by the way. That's nice. Shuddered, by the way, had a lot of issues with loading big images. Not binding. Let's name it EX 5. EX5. It will be sampler. It will be linear. A little bit more linear. To border. Let's delete this one. EX5 out HDRI. Normalization we don't need. Linear here, let's assume we have less left to gray we don't need. M-range. Let's delete everything from here. EX5. And let's save us. HDRI rug program. Okay, let's save all. Start as not set. It's not set. Yes. Let's try to reload. Okay, out normals is non-defined. Out HDRI. HDRI is equal texture load EX5 UV and zeros load VEC3 GB and the size 4002. Okay, and yeah, leave. Okay, now we need copy and 5. This one 93, 92. 93, 91, 90, and 98. Okay, copy. X3, X2, X1. Okay, let me check PTGUI. What, this one? Yes, I understand. Let's check which exposure settings I have. Source images, so image parameters. Yeah. So with 3 EV step. 2, 3, 2, 1, 0, 89, and again 4, 3, 2, 1, and let's change the binding. It's better. X3 EX1. Let's name texture load. So at this moment I just trying to load all textures into the shader. It's interesting thing that even if we have this kind of code here and we explicitly set variable for sampler and we have all definition here, we still have these textures, images, and these bindings not use it. That's correct because in compiling time shader GPU compiler do optimization and it's just removing all variables that don't use it, because here we have vec3 and we kind of float, but it's not included in our output at all, and that's why they kind of just completely remove it just to optimize GPU code. And let's do some simple blending. For that, let's do EX1 plus EX2 plus EX3 plus EX4 plus EX5. And we need to, okay, let's divide this here and divide by 5.0. So here we just blended all exposure brackets without any compensation, and we still on the same range from 0 to +1, and that's all. So we don't have any HDRI here, and it's in linear space because I when I output this I had linear space conversion, so to linear is not needed here. So let's trying. Oh, by the way, why it's X1 is not used? Yeah, 3, 5, 4, 3, 2, 1. Okay, it's much better now. Yeah, and everything used at the end. So now we need so most naive way is multiply our values by the exposure it was used. So here we have so if it's the middle one, 0 exposure, this one is -3 EV darker. So we need okay, so let's check source images. Yeah, 94. So 93 is plus 3 EV exposure compensation. So we need to divide these by 3 EV. And let's do this. How we can do this? Divide by 2 in the power of 3. So 2 in the power of 3. Is this right? 2 power 3, so it's actually let's write just 8.0. It's a 2 in power of 3. This one we will divide. Oh no, it's actually this one should be 8.0 because we have one EV step. But this one is in 6 EV. So calculator. I have Japanese location. So 6 in well, not 6. In 2 in 6 64. This one 64. This one is this minus 6 EV. This equal is minus 3 EV. This equal 0 EV compensation. This should be plus 3 EV. This one should be plus 6 EV. So here we don't touch, here we multiply by 8. And here we multiply by 64. And here we already have some 5 values. We still need division by 5 because we summarize, but in any case we... So here we have some sort of naive HDRI image. How we can... Let's just for preview do some tone mapping. 0.5. Yeah, like this. 4 times, 8 times here, and we can see it's already still quite big, 1.7. So maybe something maybe it's too much, kind of like this. So here, so we actually have HDRI here, but let me show that this naive way it's not actually correct one. Let's check how looks every of our exposure brackets as divided by 64. How we can visualize this? No, maybe it's on this one, maybe it's hard to see. We actually have some noise. We actually have these black and white clippings. Maybe it's easy to form. So if we have our values from 0, 0.0 here to 1.0 here, from sensor, actual usable range is only somewhere here we have. So it's always better to, if our sensor can give us, let's say, maybe 12 EV instead of 8 EV for standard dynamic range, it's always better to clip 1 EV on darkness and 1 EV on shadows. Yeah. And don't include these values in computation. This especially may be critical. So here we have some valid values here in shadows, but we don't have any valid values here in white colors because we already have clipped this information. So we need to suppress these values from our computation, and in the moment in this bracket we have valid values in shadows but invalid values in darkness because it's only sensor noise. And how we can do this? Let me think. We technically can maybe just create some sort of if else loop. Let me think how we can do this. Okay, let's maybe if x1. Should I do this before? I think yes, maybe I think should do this before multiplication. It's outside. They're changing the gas. That's funny. So if x1, actually we need grayscale. Let's create not float. What? Okay, let's name to gray. Gray. Yak 3 V. And I still doing it's less naive that was before, but still too naive the way return the x x plus v dot y plus v dot z. And divide by 3.0 if 2 gray of x1 bigger, let's name float dark, and let's name it 1%. Okay, let's try 1% and float light is equal 99. If gray, so intensity of pixel of x1 is bigger than light, and if smaller than dark, then we can let's create vec3 sum, and let's create it vec3 0.0, so it's a black buffer, and let's multiplier, no, let's name them multiplier, and multiplier should be float, no, integer, let's name it float, and so multiplier is 1.0. So if the value of exposure bracket inside this range, so it's brighter than darkest point and brighter than darkest and darker than light point, then we should okay, let's define vec3 x1 x2 x3 x4 and x5. Here we don't need but we actually don't need this. Then sum is, then add the values of this exposure bracket, the compensated one, to the sum. We don't need this anymore. And we will do the same for other brackets. And if we did this we pass it this if statement and we inside here, then we need increase our multiplier by 1.0. So actually wait, should we change or not? If we add, okay, let's see, maybe kind of, I don't remember, maybe 8. It's this one is 0 EV, this one is 3 EV, 3 exposure 4, exposure 3. So instead of this we need to multiply plus, and the last one 5, no, 4. This one is 2, this one is 1, and multiply 64 plus 6 EV 6, and HDRI will be sum divided by mm. Next one, yeah, x5, x4, x5, 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 x4, x5, x3, 2, x1, 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 x2, 2, 3, 4. Type parameter 4. To gray. X3. Yes. Yeah, I'm passing the sampler. Okay, let's bring sampler 2D. Oh, that's this one. Sampler 2D is, it's X, X3 B is equal texture load X UV 0. Okay, put RGB. Okay, much better now. At least we don't have yellow, but we have something plus plus x5, x4. Let's don't divide. Okay, where I did mistake. Everything equals 0. Sum. Vec3 plus maybe darker. Okay. Yeah. Okay. I'm the best in mistakes. Yeah, so it should be darker the brights and lighter the dark. Okay. divided by mm. So at this moment we already should have slightly better. Let's check out HDRI equal multiply 25. Let's, instead of this, let's see how much noise we remove it. As you can see, yeah, it's maybe not so good blending here. But at least we already have much less noise in the shadows. Let me check. Yeah. So here I tweaking. I think maybe it's too big, 0.5. And actually too much noise. 29. Yeah, so it's something to play with. 2, 1. Okay. So what other mistake in this? So this way it's a little bit better than just sum up without any filtering, but let's think what kind of errors we introduce in that way. Let me kind of, so let's assume we have one image here. Okay, maybe like this. So we use only that range, and we have, let's assume it, this one is our 5 EV distance, 3 EV distance here. Okay, let's kind of, let me maybe so here when we, so actually if I have valid value here, no, it's actually not so bad. So maybe instead of by the way, let's just check how this can looks like. Cylindrical full frame, so rectangular. No. Settings. I don't need this one. Once I don't need. Lens settings. Rectangular. Rectilinear. horizontal. It's 45. Yeah, and instead of base frame fisheye. No, it's not rectangular. Projection. Project settings. Then settings. Maybe. No. Dense database. Rectangular. Okay. Well, never mind. Cubic face, not rectangle. Okay. Yeah, kind of like this. Exposure, HDRI, source images, image parameters, control exposure, true HDRIs. Source link. No exposure set phones. That's interesting. Let's remove. Let's create new project. I just want to check if it's something looks enable HDRI mode. Merge bracket image, but align link. Okay. Yeah, we can delete source images. Photometric. Let's no. We can edit. 0, 0. The kind of we expecting this expecting noise floor. Why it again? Rectangular. 5. No. Let's set 55. Is cubic face. No. Rectangular. Tone mapping. Apply tone mapping. No. Export to mapping. West. Brightness. What? I think it's here. How we can preview this? Let's zoom in. Yeah, it's definitely better than we did. By the way, where's this? And this one. Okay. My 2. Yeah, it's definitely much better blending. Exposure automatic, HDRI flow, tone map stitch it. It's interesting. What kind of filtering it doing? Optimize, disable, and okay. Well, never tested this before. Never compared, so maybe this approach is too naive. Or maybe I compensate this too much. So 2 EV, 1 EV is twice brighter. Let me check. Let's set the 50% color. 16 exposure 1. Stupid Photoshop color settings. Let me switch to linear. Okay, 50%. Exposure 1. Yes. -1 should, yeah. So 1 EV is twice. 2 EV is 4 times. So 2 in power of EV settings. In case I have source images, image parameters, yeah. In case if I have 3 EV step, so 3 EV is 2 in power of 3. 2 by 2, 4, 8. 8. And so maybe 6. My god, I forgot the math. 6, yeah, 64. So I'm not so dumb at all. Here we're dividing. Just for experiment, let's 36. Oh, 32. Well, that's magic. Actually, this is the magic. Why I have so By the way, this can be preview your. Let's see how this actually work. Well, it's 99. Yeah, I totally forgot that. Yeah, even if GPUPad have pretty nice live view preview, it still can be save all. HDRI. And let's copy here. HDRI. Okay, HDRI. HDRI frag. HDRI frag empty. Okay, what's naming we use here? Pum. Video. This one. Oh, diff in the name. In EX. EX5 for 93, EX5 4 3 2 1. We don't need this anymore. We should change the size from X1 out HDRI. Name it's HDRI EXR RGB32F, 3 channels, 32-bit. I think it's okay. Empty raw. Okay, let's do a test. Oop. In N. Somewhere I made mistake. In EX. At HDRI. In N. Program uniform not found. Ah, yeah. Really? Should I? Yeah, I think. Peaceful. That's peaceful. Yeah. Okay. Save. HD. Okay, 5 seconds from the network drive. Okay, here we have about 11 UV. Actually, it's also have the arrow here. Okay, let's check. It sounds like 0, 0. Maybe it's because we have clipping. Okay. Maybe in that case we don't need to clip. Yeah. Well, that's interesting. Yeah, so looks like it's better don't clip, or at least not clip like this. Because, yeah, in that case, we will never have, so it's will be always the pixels, at least when we capture the sun, that always have maximum 100% value, and in that case we will always have zero here. But okay, let's think a little bit. So if we pass this step, no, I think we should set to 0. And yes, but to avoid situation mm is equal mm is equal 0. No, in that case in 0, 1, 0, and this is ternary operator. Equals 0? Question. If it's equal 0, then set to 1.0. If it not equals 0, then left as is. In that case, we just can avoid division by 0. And again, let's save. Yeah, right now it should have slightly more correct save file, more proper values, because we will not divide by 6. And okay, let's close this one. Oh, only 9. Yes, actually that should not be too much EVs. Yeah, kind of. It's interesting. Looks like PT GUI do some filtering, maybe. Do you know anything? But here you can see, so we did some kind of basic naive approach algorithm. Let me see, let's see if we can save, and let's run one more time. .6. It's actually a little bit better. Yeah, this one. But let's just completely remove. It's darker than. Let's see. Save frag. Yeah, actually don't change it too much. I'm still curious why this one looks much more smoother than my wood display. Let's set it to 0. Tone mapping. Light tone mapping. Auto boost radius. Preview. Or maybe some filtering here. Oh, by the way, some person was. Yeah. So it looks like PT go do a little bit more advanced filtering here. I guess maybe it's not so naive, just multiplication, or maybe some kind of sigmoid there. It's something for research. Maybe I will do my own research later. Ah, by the way, it's 64 actually. 64. Maybe it's not a simple average. So maybe I would set a little bit more weight for to a valid range. So in case, yeah, I think something like this. So if this part of brightness intensity values is the total mess, especially like black one, maybe in the brightness also some degradation of quality on values, but it's still most usable range is here, and this part of values should have higher weight than values here. So should be maybe some weighted average. I think it's a lot of different ways to combine merge HDRI brackets. I think it's worth to check HDRI Heaven. HDRI Heaven blog. Would Heaven HDRI. I remember that was quite interesting article. HDRI from Jorg. Maybe I made mistake, but okay. So if you want to deeply dig into HDRI merging, you should read some articles and about how to do this more properly. But again, in most cases, shaders, the OpenGL shaders or SpearV or HLSL shaders should be good enough. for this, and they can be pretty fast because again, as all OpenGL shaders, like here, they process all pixels in the same moment, near the same moment, so it will be much faster than maybe using having multi-threaded CPU code. And you can see that you can quickly iterate your code and see the results, maybe debug this without needed to recompile and wait. So it's almost everything in kind of in real time, and that's why I really like these things. I don't cover it how we can use GLSL shaders to distortion. Let me maybe lens distortion. Lens distortion? Okay, something not work. Don't save. So it's possible to pass the distortion parameters to UV coordinates, and that will give you. Let me check. This work now? Something wrong. Maybe I need. Don't save. Yes, session. I think maybe some memory details. Pageable handles. Is it? No. GPUPad. Lens distortion. It's because only frag. Shaders. GPUPad. Distorted. No. Distort. Let me show outsample. No, that's debug code. That's if. Why are you using print this texture? What? Yeah, I think this one. Okay. Yeah, kind of debug. True. So it's technically possible to pass distortion coefficients, and where is I actually doing this? Texture load. Yeah, so in texture loading command, I, instead of passing UV coordinates, that will be to false. So this is kind of original image, vertical. I can pass I can distort this based on Brown-Conradi model, or we actually can pass this UV coordinates as a ST map, because if you remember our first, maybe if you remember, let me open maybe. Oh my god, it's here. GLSL. Start. Don't save. So here, if we will vec3, UV 1.0. So here, that's maybe how a ST map looks like, and I actually did. Let me check. Maybe I can show quickly. Again, dumb test. No, it's not binary decomposition. Displacement and distort. Okay, I will not show you this one, but we can generate a dummy image. Let's say this one is 406,000 ST map. We can generate this image and pass this image to PTGUI to our, let's just quickly do this thing. Enable HDRI, enable. Okay, let's maybe I made mistake. Wow, it's already a lot of time. So we can create a test panorama capture and use this kind of ST map as a replacement, and export this these distortions from PTGUI and use them as a source for UV coordinates, so it will work as distortions and do undistortion for our images. But again, maybe I will do another live stream about this. So let's sum up what we did today. We experimented with GLSL shaders inside GPUPad open source tool. We did some quick rough stupid tests in these shaders that was worked as an input for RawGL. Photometric stereo, to good example of using the shaders is a photometric stereo inputs. Next one is a good example that needs some experiments is HDRI. For that, I think, well, let's finish for today. I hope it was interesting for you. Please subscribe if you like this. With likes, I like your likes. YouTube like your likes. People likes videos that have a lot of likes. Yeah, subscribe to my Patreon. I will have something more interesting to explain for you too. If you have some questions, please write your questions in this video or on our 3D scanning Discord, or just somewhere on Twitter or on LinkedIn. You can ask me and I will try to answer to your questions. Well, it was a long video. I slightly brush up my knowledge in GLSL that I actually not use it for quite a long of time. And yeah, I hope it was interesting for you and maybe you will do something really useful at the end. So thank you for everyone.